All right, if you're watching this video, it's because you might have missed a day on this week for the geometry class. And this is chapter 2, numbers and more. And so we're going to go ahead and talk a lot about some of the basics of geometry here in this chapter. And if you want, you can also fast forward this. If you notice, the video is broken down into pieces for like day 1, day 2, day 3, day 4 for all 4 parts. And just make sure you guys have your pencil, your paper, and you guys are listening and paying attention. It's a really good way to get caught up and feel like you didn't even miss a day. Okay, so we're just gonna go ahead and get started. Um, Here's the packet. Make sure you put your name. Make sure you put the period. I'll give you your score. But in terms of your score, it's really easy to know how much you earn because every section tells you the number of points. And each page is worth 10 points front, and then the back is another 10. So technically each page is 20 points. And then the entire packet is worth 100 points. So let's see if you guys can go ahead and follow along with me. The first word is a number line. And a number line is a mathematical concept used to represent quantities or positions, and it can be a whole, a fraction, or a real value, and that's some of the things that we're going to talk about here. Here we have 4 number lines, the natural numbers, we have the integers, the rationals, and the reals. And just understand that there's a lot of different types of number lines, but these are the 4 ones that I think are the most important. And one of the things about numbers that you should understand is their technology, and they kept evolving over time. The first couple numbers weren't as good, and some of them had to do with like religious reasons, like say the Catholic Church didn't want to advance or progress mathematics, and then some other reasons where our sciences weren't there yet, so we weren't there mentally. Like we also had to evolve to also be able to understand the next levels of number lines. So some of the stuff was like us holding ourselves back, and then the other parts was like our intellect was holding us back. But nonetheless, let's go ahead and get started. So the first numbers were called the natural numbers, and this is what we call the counting numbers. That's a test question, counting numbers. And the counting numbers were just that, you count. And there was no zero. It started at 1. So it went like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it kept going. And one of the things that I want you to understand is this went on forever, and so this was positive infinity. And within the numbers, you can tell that it's going to go on forever. So that's infinity. That's the first infinity that you guys are going to be introduced to. But I want you guys to also understand that there's different levels of infinity. Some infinities are bigger than others, and I'm going to show you in this packet what I'm talking about. So let's take a look at the next number line. So the next one is the integers. The natural numbers didn't have a 0. Okay, so where's the 0? The way I learned it is that the Catholic Church didn't want to acknowledge the 0 because then people would then start to think about nothingness, and they didn't want you to think that nothing happened or nothing exists. So like, for example, when you died, they wanted you to think that you either went to heaven or to hell, but I guess not existing was worse than either like the most best thing or the worst thing, So the Catholic Church didn't want to accept zeros for a really, really long time, and then eventually they had to like accept the fact that there's such thing as a 0 in order for us to continue to like advance. The other thing is because of the no 0, there was also no negatives. But eventually the integers, these are what we consider the whole numbers. And there was a 0, and there was still an infinity in one direction. So this is positive infinity. And there was also a negative infinity. So what's interesting about this is infinity just got twice as big. So it went off in this direction and it went off on that direction. So now this is like times 2, okay? Infinity just got twice as big. Now, rational numbers or the quotients, these are just basically just fractions. And we're gonna show this with, let's say with 1 and 2, okay? So one of the things that I wanna show you is that between 1 and 2, another infinity exists. And technically, a bunch of infinities exist between every single number, okay? So there's infinity between 0 and 1, there's infinity between 1 and 2, infinity between 1 and 3. There's infinities between every single number. Why? Because we can keep chopping this up forever, and we can keep cutting it and cutting it and cutting it and cutting it. And now I know I'm running out of space, but you can zoom in. So if I get this closer to you, all right, if I get closer, we can start cutting it up and cutting it up and cutting it up and cutting it up, and you can keep cutting this up infinite amount of, like, it keeps getting smaller and smaller and smaller. So infinity lies between every single number for that matter. So infinity just got way bigger. And now the real numbers, what's interesting is there's such things as irrational numbers. Irrational numbers. And irrational numbers are numbers such as pi, which is like 3.1415 and maybe 9. I don't really remember. I don't have it all memorized. But basically, this goes on forever for infinity. So, and look, it's just one number. Like if I would have changed this to a 6, that's a totally different number, and you can keep changing it up. So all I'm saying is between all these regular numbers in here, there exists so many of these irrational numbers. It could be something like phi. Phi is a well-known irrational number, 1.618, and it goes on forever and ever. But basically, numbers go on forever themselves. So all I'm trying to show you is that infinity is everywhere. And that makes me think like my life is not necessarily infinite, but my point is infinite in that it's unique. And your life, my life, everybody's life's unique. And so you have to be awake. You have to wake up. You have to be conscious. You have to understand the choices that you're making, and not just your choices, but like everything about you is special. It's unique. So I could have just as easily grown up and said, okay, my parents are farm workers. I worked in the fields when I was in high school, and I could have chose not to go to school, and I could have been working in the fields right now. Who knows? Maybe I would have been a manager, but I chose not to do that. And I chose to go to school and college and graduate, become one of the youngest teachers ever. I then also started my own business. I ran for city council, became the youngest mayor in the history of the city of Hueneme. Like, the reason I was able to do that is because I felt all this infinity, like everywhere. Like I felt it. Like, I'm like, you know what? I can make something of myself, and you can make something of yourself too. Hopefully you see it in these numbers right here. I'm trying to do my best to paint a picture of uniqueness. Like, some of my heroes are like Kobe Bryant and Albert Einstein, and I can try to think to be like them, but I'm never gonna be like them. And you're never gonna be like anyone. You're not gonna be like me. You're not gonna be like your brother. You're not gonna be like your parents. Everybody's gonna be different, and that made me feel powerful. Okay, it made me feel special, and you should too. Like, you control your destiny. Let's turn the page. So there are many different types of ways that you use numbers, and I want you to explain in both words and drawings, and I also want you to use color. But we use numbers to count. So in class, I was counting my students. And so this was like really like the first way that we started using numbers. So we can do 1, 2, 3, 4, 5. I don't want you guys to use my picture. I want you guys to use a different picture, but counting students or counting people. All right. You can use anything, but you got to use an example of something that you use to that you count. Okay. Now you also measure. I got a ruler right here. So this is another thing. You can kind of see it like counting, but this is measurement. This is measuring. So let's say I have a plant. Okay. And I want to measure it, so I'm going to put a ruler right here. And I'm going to measure it, and I'm going to say that this is 9 inches tall. Okay. And I'm just going to write a little sentence saying, like, I like to measure the growth of my corn. In Spanish, it would be milpa. So measuring a plant with ruler that's in inches. Okay. So you guys are basically drawing examples and explaining how numbers are used in real life. In terms of calculations, I know most of you guys have calculators. There's so many types of calculations you can do. So you can say, I have 3 classes. And in my first class, I have 26 students. In my second class, I have 16 students. And these are my real numbers, by the way. And then in my last class, I have 24 students. If I want to buy all of my students burgers, each a burger, how many burgers am I going to need? I can use my calculator, or I can just add. So 6 plus 4 is 10, plus 6 is 16. Carry the 1, 2, 3, 4, 5, 6. I have a total of 66 students this quarter. Okay, so calculation. And then representation is one of the ones that's a little bit harder to understand, but this is like your address number, your jersey number, barcodes, bank number, ID, your phone number. These are basically numbers that aren't, and I'm going to use a jersey. Okay, and my favorite number was 9, so I'm going to say Martinez. Okay. This is not calculating. This is not measurement. My number does not decide how good I am of a basketball player. And it also doesn't mean that I'm counting. Some basketball teams don't have an 8 or a 7 or a 0. Like, it's just random. Like, people just pick numbers. It's numbers that they like. So that's why I call this representations. Now, the last thing I want you guys to do is explain which one of these is the most important and then rate them. So you can say, if you think that counting is the most important, then put counting at the top. So most down to the least. And then just write them down like 1, 2, 3, 4. I'm just curious, okay? That's all this is. You're getting 2 points for this. So go ahead and do this. So from most to least down over here should be pretty simple. So that's day 1. We're now going to move on to day 2. Day 2, we're now talking about dimensions, okay? A dimension it's a direction. It's measurable, and I think those are the 2 most important things. So that's what you would underline. But one of the things that I want to explain to you about dimensions is, look, first of all, yes, we live in a 3D world, but guess what? You're watching me in a 2D, form because I'm on a video right now. Does that mean I'm two-dimensional? No, just what you're watching is two-dimensional. I actually think that we are, experiencing and living in a multi-dimensional experience. So hear me out, because I don't want you to think like that I'm crazy or whatever. Keep in mind, I've done a lot of math. Like, I have my associates, my bachelor's. I did my single subject in math, and so I've been teaching math for the past 10 years, and I've taught every single type of math, as high as calculus and as low as arithmetic. And then I've also, technically I didn't finish my master's in math, but I took most of the classes. I just need to finish my thesis. It'd take like 1 or 2 more classes. But basically what I learned is, in a lot of those math classes, like, and some of the projects I had to do, I kind of had like this epiphany where I was like, you know what? You can experience reality in multiple dimensions. Sometimes you experience them multiple, like 2 at the same time. And I want to explain that to you in just like right now. So let's go back to the paper. So 0 dimensions, this is a point. You cannot move. Cannot move. Technically, there is no space, or no width, no depth. You're like stuck. And this is kind of how I feel like people are. Like, you're in your body and you can't leave your body. So I got a little bit of spiky here right now. So you're stuck in your body. So that's how I say you experience the 0 dimension. Now that point is just a point in space and time. 1 dimensional is like, think if you got that one point and you drag it back and forth. And so now there's many points. And this is what I consider, in my opinion, time. Okay? It's linear. It's basically a line, and it goes forward and backwards. Okay? And I know we're always going forward, but you might say, Mr. Martinez, well, how do we go backwards? Well, use your mind and remember, if you're here in this time, you can use your mind and remember like when you were born, or maybe not when you were born, but maybe when you were younger. So you can go back, and you can even go forward too, like imagination. In 2 dimensions, it's now this line being, so if this is the line, you're dragging it back and forth, and it makes a flat piece of paper. Okay. This could be like the way that you see with your eyes. I know this is kind of weird, but everybody has 2 eyes, and the 2, I almost think of it like that's your 2D part, because with your eyes you see a screen. Okay, that's how I think people experience 2D. So like, I'm looking out right now, I'm like, okay, this is my screen, and yeah, you can move your screen because you're in 3D. Okay, and in 3D you're like in a box, and so you can move around in like a lot of different directions. And this is probably the most fun, and this is probably where most people experience most of their life is through movement. Okay, you can jump, you can run, you can go forward and backwards. This is why we all say that we live in 3D. Okay, all right. Now some of you guys might say, well, Mr. Martinez, yeah, we're in 3D. I get how we're a little bit of that, but how are we in 4D or anything higher? 4D, you have to understand that it's a direction you cannot see. Okay, you just can't see it with your eyes. And so I say that you use something else to see 4D, and I'll talk about that in a bit, but let me explain something else first. If you live in a 2-dimensional surface, okay, let's just say there's people on this piece of paper, and this piece of paper is actually 3D, but let's just say it was a 2D, all right? Well, the people living on this piece of paper, they can't see us right now, or me, They can't see me because they can only look around and look around like in a circle, in a flat circle. Okay. They can't actually look up and they can't actually look down. So that's why they can't see us, because all they see is a little line stuck within the paper. So a fourth dimensional object, in my opinion, sees the 3D people, but they don't see, like we in 3D can't see the 4D. And I almost see it as like all the different possibilities of the three-dimensional world. So in my mind, I can see, okay, I can become a doctor, I can become a lawyer. There's all kinds of things that I can imagine, and I think that's like what fourth dimension's like. And what do you use to see 4D? You use your heart. Okay, you use your heart, you use your mind, and you can visualize and you can feel all the different possibilities. So we're not really in like 4D all the time. I think of this as more like your imagination. And I do always kind of draw like a square, but it's like it goes in and it goes out, because you have to feel it on the inside and then see like your life is possible in like the extremities of this universe, like the ends, like anything is possible. So I'm trying to be inspirational in here, and like I'm just trying to tell you, you as a student, you can become anything that you want to become, because anything is possible. I think in the 4D. 5D and higher, like maybe I'm not there yet. Maybe you can help me out. I have some ideas, but they're a little bit abstract, and I don't know if they're a little bit too out there, but I have some ideas. If you want to talk to me about that, we could talk. But yeah, I do believe in lots of dimensions, and I believe that we exist in some aspect of either of these dimensions at one time or many times at the same time, or not, so I don't know if that made sense. Sorry if I confused you, but dimensions, it's like a tricky thing. Nonetheless, out of all these dimensions, the second dimension is the one that we do the most, because all of our stuff is it's on paper, which is, so that's where most of our math is actually done, and that's where most of our stuff is done. So we're going to talk about 2D right now. So this is 2D. This is a map, this is a map, this is a map, this is a map, and we're gonna keep evolving. In this part right here, we're gonna label one with numbers. The bottom axis, we're gonna use numbers. And then the top axis, we're going to use letters. So I know you guys have seen maps before that do this. Let me see, A, B, C, D, E. That's where I messed up. So A, B, C, D, E, F, G, H, I, J. I'm just going to skip a couple letters. Doesn't matter, okay? I think you guys get the point. But this is like the easiest way to label stuff on 2D, because you can't really get the order wrong. Like this is G6, but it could also be 6G. This is 3D, but it can also be D3. So it makes it easy for kids and adults to be able to label stuff. This is more for like Disneyland, like Six Flags, like, I don't know, fairs. They use these types of maps for like amusement parks. But the truth is that they have limitations. Why? Because letters, we only have 26 letters. And what if I want to be specific? What if I want a spot like right here? Like what spot is that between half an A and 3.5? So the next evolution of this map is just using numbers all together. And when it comes to this map, now we have numbers that repeats. There's a 3 here, and then there's a 3 there. So we need to have order. And usually when we do graphs in this manner, we always label the x-axis first and then the y-axis. So if I put let's just say a dot here. I'm going to say that this is 7, comma 2. Okay, everybody understands that we go left and right first, and then we go up and down. So let's just say I label something right here. This is 6, comma 9. Another one, let's try this one. 2, comma 6. Remember, the first number is always how much you move left and right, and then the second number is how much you move up and down. And if you need to remember how to remember this, I always tell my students, think about a bird. The bird moves left and right first within the nest, okay? And then the bird flies and it goes up and down. So first left and right, and then up and down, okay? So hopefully that helps. But then again, this has limitations. Why? Because what about this space over here, okay? So we now have to incorporate negative numbers. So this x-axis, still the same, okay? This becomes 1, 2, 3, 4, 5. And then on the left side, this is -1, -2, -3, -4. We can go up 1, 2, 3, 4, 5. And then these are now negatives, okay? Very similar to this one. I can place a dot here. That's 2, comma 3. I can place a dot, let's see, right here. This is -4, comma -1. So just know that this quadrant. Now we have quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now what's interesting is when you look at a map. In a map, we don't have negative numbers. Okay, and I think the reason we don't have negative numbers is because you don't want to be a country that's on the negative side. Why would anybody want to be on the negative side? Everybody takes pride of where they're from, like Spain, England, Brazil. Like, if that was the case, then Brazil would be on both negatives because they're south and then they're west. So negative, negative, they're not going to be cool with that. So what happened, and what I think happened, is they decided to kind of convert back to letters, and then, but instead of using a bunch of letters, they just decided if you go left, that's west. If you go right, that's east. If you go up, that's north. And if you go down, that's south. Okay? And we did use 180 degrees this way, 180 degrees that way, but the funny thing is we only go 90 degrees up and 90 degrees south, okay? So this is gonna make more sense on the back side. So let's turn the page over. And so I'm gonna do 4 for you, and then I want you to do 6 cities, and you have to find the coordinates and also label them on this map. Okay, so I'm gonna do a couple for you. So let's do Camarillo. Camarillo's like right here. LA's like right there. Camarillo, LA. Then we're gonna do New York. And then we're gonna do Dubai, which is somewhere, I think, over here. Okay. All right. So how far is Camarillo from LA? It's about an hour away if you want to think about it in terms of time in a car, driving at about 60 miles an hour. But they're very close. So let me show you. So Oxnard or Camarillo is about 34.19 degrees north and 119.17 degrees west. Okay, why do I say north? Because this line right here, let me see if I got a marker. This line divides the world in half. Not literally, all right? And then there's the reason why they divided is because I think England was the one that first started using the system, and so they're like, we wanted to go through England, you know, so because we are the ones that started it. So there's actually a city, or I don't think it's a city. There's a place in England where it's called where you actually see the line. It's Greenwich, I think is what it's called. Don't quote me on that, but so this line is imaginary, and so is this. Technically, they're all imaginary, but the only one that really makes sense is the equator, because the Earth it's spinning, and the way that it's spinning is like we know that it's going in a certain direction. Okay, all the other ones, they're just made up. We just decided that's the vertical one. So notice back on the map, anything on this side is north. Anything on this side is south. And then anything on this half is on the west, and anything on this side is east. So since these dots are on this side, they're going to be both north and west. And so that tells people that if you want to get to Camarillo, you got to go 34 degrees north, so 15, 30, and 34, somewhere around there. And then 119 degrees west, which is almost 120. So you see that? So that's why this says 20. So technically, I drew it a little bit more to the left, and it should have been a little bit more to the right. What about LA? LA is 34.05 degrees north. Okay, so it's a little bit lower than Camarillo. And by the way, this is where we're at. This is our school at Frontier, FHS. And then in terms of west, it's about 118 degrees and 24. So it's only about a degree. Okay, so maybe like you can think of it like a degree is about an hour, about. So this might be like 118 hours. That's intense. New York looks like it's about 75 degrees west. It's really 74, but let's see. It's 40.71 degrees north and 40.7. Excuse me. I think I messed up. Not 40. I was looking at the same number. This is 74 degrees west. Okay. Dubai, the reason I picked Dubai is because what's interesting is if we want to get to Dubai from LA, it's almost halfway if you go in this direction. Either you go left or right, it's about the same distance. It's almost halfway. Almost. Dubai is really 25.27 degrees north. So it's still on the north side. And then in terms of the east, this is now east. It's 55.29 degrees east. Okay, and I forgot to put a W there. So go ahead and pick 6 cities and label them on the map and give me their coordinates. We're now gonna move on to part 3, numbers and more. Part 3 is some of the basics of geometry. I just feel like I need to stretch a little bit. It's been a long day, man. I had to re-record the other video. And the other video was about like an hour, and as you can tell right now, this video is like 33 minutes. So it's been over 2 hours of recording, and I still gotta edit, I still gotta publish and post it on Google Classroom for you guys to watch. So anyways, let's get to it. So part 3. What is geometry? I'm gonna let you answer that on your own. So I want you to think about that, because we've already talked a lot about geometry on our first week. But there are a couple vocabulary words that I want you to know. So we know what a point is. Points are usually labeled with letters. Okay, letters to label. Remember, they have no point, no width. Okay, no width. They're just basically a location. That's what it is. A segment is what most people think of it like a line, but A segment is not a line, it's like a piece of a line. So, and then this is how we denote segments. A line, if I jump over here, goes on forever in both directions. Okay, and then it's denoted like this. So F, G, and then a ray is kind of like a cross between a segment and a line, in that it goes on forever in one direction, and that's it. Okay, and then this is how we write array. So that's array, or we can also say YX, but then you got to put the arrow on, facing on the Y, because the arrow is on the Y end. Okay, so you can flip it. Parallel lines, these are lines that will never touch, and the way we show that is by putting arrows in the middle facing the same direction, usually 2 arrows, and so they'll never touch. And then a perpendicular line is almost like the opposite of never touching. They definitely touch, but not only do they touch, but they touch at 90 degrees. It's like perfectly standing straight up. Okay, so there's an intersection. And when we build homes, this is usually what we want. We want perpendicular. We don't want the angles to go in or out. So just kind of keep that in mind. A vertex is a corner. So if I draw an angle, it's a corner. Pretty, I guess, self-explanatory. This is an angle, but the vertex would be that corner. Where if we have a shape, that's a vertex, that's a vertex, that's a vertex, that's a vertex. All these corners are vertex. A plane, we already said, it's like a flat piece of paper. An airplane, okay, so if I said airplane, it's like a plane in the air. So just imagine like these are people walking around, and then they see an airplane. I don't know if this is a good airplane. Dang. Okay, but they're flying on a plane on top of us. Okay, so that's why we call them airplanes. And then I just threw on a curve because in geometry we don't really talk about curves, but I think you guys need to understand that this is not a line, this is a curve. Okay, most people would just call that a line, but in terms of geometry, this is a line. This is a curve, and a curve usually has at least 3 values, but we're not going to get into this too much. This is maybe a little bit next level geometry, but just want to explain a couple vocabulary words. And then from these vocabulary words, you guys are going to flip it over, and you're going to use those definitions, and you're going to draw a picture. Now I'm going to draw a picture right now for you, but I want you to not copy don't copy my picture. You want to get creative. So I give the students in class plenty of time to come up with stuff, and I love it when you guys come up with something different. So for me, I did draw the horizon. Okay. And I drew a road. Let's see if I can draw a road. Okay. And okay. So these lines, even though they look like they're gonna meet, these are parallel, all right? Parallel. So that's one of my first words. Okay, I got 1 out of the 9. Then I'm gonna draw some mountains. Okay. And I'm gonna say that's a vertex. That's a corner. Vertex. So now I got 2 words. Okay, let's see. Let's say this entire land, that's my plane. Okay, it's flat. Okay. What else? What else? So I got 3 words. I'm gonna draw a sun. And then the sun is setting, but the sun itself has rays. Okay, so these are rays. Okay, I got 4 words. What else do I want to do? Let's say that let's say there's a sign on the middle of the road. It says welcome to Arizona. Okay, this sign is perpendicular to the ground. Perpendicular. So we got 1, 2, 3, 4, 5. We need 4 more words. So I think I'm still missing a point. So I'm going to draw myself in the middle of the road. And I'm going to say where I'm standing. That's my point. Okay. I need a segment. The lines on the road. That's a segment. So I got 1, 2, 3, 4, 5, 6, 7. I'm missing 2. So I'm missing, I think, a curve. And I'm missing a line. Okay. So let's say for a curve, I can draw some hills. And then a line, that's going to be tough, man. A line goes on forever. So I'm just going to say my life going forward and backwards is a line. Okay. I don't know if that's cheating, but I'm going to draw a couple more things. All right. Just to kind of fill it in. That's my painting, or that's my drawing. I want you to get as creative as you can possibly get when you do this assignment, because I do give you plenty of time. And if you can use some color, I'll give you guys some extra credit. We're almost done. Okay, almost done. So for the last assignment, like I said, I'm just a little exhausted. We're gonna use this. It's called a protractor. It's used to measure degrees. So that's what we're gonna go ahead and write right here. A degree, in the context of measuring angles, is a unit of measurement representing a full rotation. A circle is 360 degrees. That's your answer for the back of this worksheet. And just quickly, I'm going to teach you guys how to use a protractor. So a protractor, you got to make sure that you find the corner right there. You see how there's a line that goes up, and then there's a line that goes left and right, and up and down. You're going to go ahead and place it at the corner of this angle. You're going to place it right on top, and then you got to make sure you label it, align it up with this line. So this line is going to line up with that one. So you put it right on top of it. And a lot of students in class were saying that this was 140 degrees. Why? Because if you see this angle, it points at 140. But the funny thing is, it's not 140 degrees. This starts right here, so it goes 10, 20, 30, 40, and I actually think it's a little bit less than 40, so I'm gonna say 39. So notice that the 40 is actually on the 140. So you have to be careful on which one is it. Is it 100? Is it 80? Is it 70? Is it 110? You just have to be careful because it depends in which direction you're opening. If you're opening from left to right, then you're going to use the numbers on the top. If, like in this case, you're opening from right to left, then you use the numbers on the bottom. Okay, so you have to be very careful. So I'm going to say this is 39 degrees. This is a flat circle, or a flat half a circle. That's 180 degrees. Just know that if you put it on top and it's just flat, this is 180. That's why you see 180 here and 180 there. This might be 90. Let's see. I'm going to put it right on top. And it's 90, so let's change this from a from this to a box. When we do a box, that means it's 90 degrees. Go ahead and label the rest of these. You might have problems with these two. See if you can figure it out. If you can't figure it out, ask somebody in class because we talked about this, or ask me. The trick is knowing that this full thing is 360, and maybe if you measure this on the inside, you can somehow figure out what's on the outside. Okay? I know I'm making this lesson kind of short, but trying to finish up. So we're now gonna draw angles, and we're gonna use the protractor. I already told you guys how many degrees is a full circle. So go ahead and write down your answer for your 1 point. But for this one, I'm gonna have you guys draw a line and a point. And I wanna measure 10 degrees. I'm gonna put this on top. Make sure the corner touches that point. Where's 10 degrees on here? 10. So I'm gonna put a dot at like 170, okay? And now I'm gonna connect the line. I mean, those two dots to make a line. That's 10 degrees. Now what's funny is most cars can't even really go up 10 degrees. Like if you go up the grade, the one here going up from Camarillo to Newbury Park, that's a 7-degree hill. You can see them on the signs. It's tough. Like when you go up it, you can even hear the car's engines like going up. But go ahead and draw lines for all of these. And then go ahead and draw a dot. And this one's 30. So I'm gonna line it up right there. Make sure they're fully lined up. And at 30, in this case also 150, I'm gonna put a dot, and that's gonna be my 30 degrees. Go ahead and label it 30 degrees. And you guys are gonna do the rest of these. I think I'm done for the day. You might struggle with this one, but you can ask me for help. I don't want to do the rest for you guys. I want you guys to do them on your own. So again, if you guys have any questions, let me know. You can write a comment on the video. You can email me. You can wait till we're in class. Hopefully you guys had a really good time, with this lesson, learning a lot of the basics of geometry. There's a lot of stuff that we discussed. We discussed number lines, dimensions, vocabulary words, and now we're doing angles and we're measuring. And one of the funny things is that next chapter is all about measurements. There's so many things that we can measure in mathematics. So be ready for that. Next week's gonna be fun. Can't wait to see you guys. Everybody be safe. And, give this video a like or something. I don't know. All right? You guys, take care. Bye.